Hey guys, this is going to be the video covering section 6.4. It's going to be similar to what we covered in 6.2, I believe it was, except for this time, instead of having a coefficient of 1 in front of the x squared problems that we did with trinomials, putting them into a binomial times a binomial. This section is going to cover how to work those problems, how to factor those problems that do have a coefficient greater than 1 in front of your as your a coefficient. So if you look at the objectives on the 6.4 PowerPoint, we only have one objective for this section. It's a lot shorter section compared to the others that we've been through. We're going to use the grouping method to factor trinomials of the form ax squared plus bx plus c. So as I said, the letter A is representing a coefficient larger than 1. Okay, so I went ahead, this is straight from the book, but I made a slide on the steps for factoring trinomials by grouping. So I'm going to read through this, and then these are the steps that you can always refer back to as we work through today's lesson and when you go back through and do your homework problems as well. All right, so the first thing you have to do is to factor out the greatest common factor if there is one other than 1. So always start with looking at the whole polynomial and saying, can I factor out a coefficient or can I factor out a variable? For the resulting trinomial, which is now we're assuming in the form of ax squared plus bx plus c, find two numbers whose product of a times c is the sum of b. So you're going to notice that the way we factor when the coefficient is 1 on a is a different method than how we do it when there is a coefficient larger than 1. So you're going to see a similarity of how we did the other section, but you're also going to see a difference. After you do step 2, step 3 is to write the middle term as bx using the factors found in step 2, and that step will make a lot more sense when we get ready to go through these together, and then factor by grouping. All right, so let's go ahead and take a look at example 1. Okay, so when this coefficient was 1, what we were trying to do is find factors of c that would add up to b. But because of this coefficient being larger than 1, our strategy has to change. So rather than looking for factors of 8 that make 14, you're going to do a times c. So 3 times 8. So you'll take a times c. So in this case, 3 times 8 equals 24. So we're not taking factors of 8, we're actually taking factors of 24 that add up to 14. Okay, so I'm going to go through my factors of 24. Obviously 3 and 8 are two factors because we just got 24 by doing that. But if I were to add 3 and 8, that only gives me 11. So those aren't going to be the right ones. I could have 1 and 24. That's not going to work. 2 and 12. So 2 and 12 is going to end up being what we're going to use, because notice that these are both plus signs. So I am looking for factors of a times c, 24, that add up to 14. 2 times 12 is 14. All right, so what we're about to do is a lot different from what we did in the last section. We are going to actually write the whole problem again. We're not to the part where we're going to be putting it in binomials just yet. I'm going to keep it, we're not putting any parentheses just yet. I rewrite 3x squared, but instead of writing plus 14x, what I'm going to do is take my two factors and I'm going to put them in place of the 14x, but it still makes it a true statement. So plus 2x plus 12x plus 8. So if I were to add these like terms, 2x plus 12x, I still get 14x. So I'm not changing the value of anything. I'm just rewriting it in a different view. Now, the reason that we're rewriting it like this is because if you look back at your steps, once you rewrite it with the factors now taking place of it added together, then we're going to factor by grouping. So if you remember back to 6.1, that was the very first section we covered in chapter 6, we learned how to factor by grouping. So what that means is you take a portion of the whole entire polynomial and you group them and factor out those groups separately. So what we're going to do in this method, you're not going to have to rearrange anything. This method will work the way it is. You're going to take the first two and the last two. Now this doesn't mean that we're breaking this into polynomials, this times this. We're just grouping this because we're now going to factor out. So I'm going to look at just these two terms right here. What can I factor out between 3x squared and 2x? Well, obviously 3 and 2 don't have any common factors other than 1. So in this case, the coefficients can't factor out, but I have an x squared and an x. So in that, we do have a greatest common factor of x. They both have at least one x. So I'm going to go ahead and factor out an x, put my parenthesis, and write what's left. So here, I still have my 3. I had 2 x's. I removed 1, so I still have 1 x left. This plus sign remains. I didn't take the 2 away, so that's still there. I had 1 x, I removed it, so I'm left with 2. All right, now this next part, there does need to be either a plus sign or a minus sign separating these two sets of parentheses that we're about to do. I noticed that this has a plus sign and this has a plus sign. So that means I'm factoring out a plus, okay? So on this, I'm gonna look at now 12x and 8. What do they have in common? Well, 8 doesn't have an x, so I'm not gonna be able to pull a variable out on this. It's gonna have to be a coefficient. Of 12 and 8, I know that they both share the factor 4. So I'm gonna put 4 on the outside, and on the inside, since it's coefficients this time, we're dividing. 12 divided by 4 leaves me with 3. The x remains. This plus sign stays. 8 divided by 4 is 2. Now, take a look at your problem. What do you notice? The part in the parentheses are exactly the same. 3x plus 2, 3x plus 2. So when you do factor by grouping, the goal is that you'll have a similar set of parentheses of the same, I guess, binomial inside them. So because both of these share a 3x plus 2, that means I can factor out that 3x plus 2. So I'm going to write 3x plus 2, and then I'm going to write parentheses and what's left behind. So if I take away 3x plus 2, I'm left with an x, this plus sign. And if I take away 3x plus 2, I'm left with 4. So now, notice we went from this to a binomial times a binomial. So this process is what you're going to use anytime the coefficient in front of the x squared is greater than 1. Okay, so I would like you to go ahead and try this on your own. I'm going to work the practice problem on the board so you can check your work. And I will be erasing this so I have space to do that. If you haven't opened your books yet, the practice problem can be found on page 397, practice 1. All right, so go ahead and take a look at the answer. See if it matches up with yours. Just to go through it really quick, 5 times 12, A times C, that's what the factors we're looking for. So we're looking for factors of 60. I needed 2 factors of 60 that will add to 61. So I started off with 60 and 1, and that just happened to work. So I took my 2 factors of 60 and 1 and split it up. So 5x squared plus 60x plus 1x plus 12. From there, divide it into the first 2 terms and the second 2 terms. So in the first one, I have 5x squared plus 60x. They both have a factor of 5 and they both have a factor of x. So what's left behind? X plus 12. They both have a plus here, so I know that the in-between sign is going to be a plus. So from there, then x and 12, you can't factor anything. So if you can't factor anything, then that's just what's left in that particular grouping. So I have x plus 12. But if you notice, x plus 12 ends up being the binomial that they both have in common. So I factor out x plus 12 and I write what's left behind. So when I remove the x plus 12, what's left? I have a 5x, a plus sign, and then the factor on the outside of this is invisible, so that means it's just 1. All right. Okay, so moving on to example 2. We are still working with the same strategy, but notice the signs are different now. So we have 6x squared minus 13x plus 7. So if you remember back to the last section, when we have a minus sign and a plus sign, the plus sign means that the factors are going to be the same sign. So they're both going to be positive or they're both going to be negative. But the sign on letter B, in this case 13, because this is negative, that tells us that they're both going to be negative. So I'm still looking for factors that add. It's just going to be negative adding to negative. So based on our strategy, we take A times C. So 6 times 7 is 42. I need 2 factors of 42, the negative versions of them that add up to negative 13. Well, I'm going to go ahead and just use 6 and 7 as my first group of factors, and I just happen to notice negative 6 plus negative 7 adds to negative 13. So we already have what we're looking for. So I'm going to go ahead and rewrite it. 6x squared minus 6x minus 7x plus 7. So remember, when they're negative, you don't want to write plus, you want to write negative. That's why it's important to figure out what your signs are going to be before you replace them in the problem. Okay, so from here, I group them. And notice I am grouping this sign, okay? It's going to be really important that you know what the sign is on this number because it will affect when you get ready to factor. Okay, so in the first one, I'm looking for greatest common factors. I notice they both have a 6, so I'm going to pull that out. Whoops, I guess I don't need that yet. And I notice they both have an x, so I'm going to pull that out. What's left behind when I pull away the 6 and one of the x's? I'm left with 1x. The minus sign carries. I had 6x and I removed 6x. So remember the rule. Whenever you take away or you factor out the exact same term, then you're left with 1. 6x divided by 6x is 1. All right, now here's why it's important to group this sign. Because I notice that this sign is negative, I'm going to go ahead and write negative, but I'm factoring out a negative from this entire set of terms. So that doesn't just mean that I'm taking a negative away from this 7x. That means I'm taking away a negative from this plus 7. So anytime you factor a negative from a group of terms, You're changing the sign on everything on inside the parentheses. So that means right now, this term is negative and this term is positive. So if I take a negative away, the first part is going to become positive and the second part is going to become negative. Now, before I do that, I want to go ahead and know what am I factoring out. So I guess I really shouldn't have put that parenthesis yet. Okay, so looking at both of these terms, I notice that they both have a 7. So I'm going to go ahead and pull a 7 out as well. All right, so I'm looking for what happens when I remove a 7 and what happens when I factor the negative. So the opposite of negative 7x, I took away the 7, so I'm left with a positive x. Here, this is positive, so if I factor out the negative, the opposite of this positive is now negative. I had a 7, I removed the 7, so what am I left with? 1. You could look at it as 7 divided by 7 is 1, okay? All right, so now notice we have x minus 1 and x minus 1. Exactly what we're looking for. We're looking for a matching binomial. So I'm going to factor out the x minus 1 and write what's left behind in parentheses. So if I remove x minus 1, I'm left with 6x minus 7. And that's my answer. Okay, so you go ahead and try the practice problem. I'm going to erase this and rewrite the practice problem, and you can check your work with me when you're done. So we're going to be on page 397 if you haven't looked yet. Oh. Okay. Okay, so going over this problem, I went through several factors of 60 until I was able to reach 2 that added up to negative 19. So remember, this tells me they're the same signs. This tells me which same signs. So I'm looking for 2 negative factors that multiply to equal 60, because 12 times 5 is 60, but add to equal negative 19. So I went through all of these until I got to negative 4 and negative 15. Negative 4 times negative 15 is positive 60. Negative 4 plus negative 15 is negative 19. So I rewrote it. 12x squared minus 4x minus 15x plus 5, and then I grouped them into the first 2 and the second 2. In the first 2, I can factor out a 4 and I can factor out an x. So what's remaining? 12 divided by 4 is 3. I had 2 x's, and now I have 1. The minus sign carries. 4x was removed, so since I removed the entire term, I'm left with 1. I had minus 15x plus 5. I factored out the negative sign, and I factored out a common factor of 5. So what's left behind? 15 divided by 5 is 3x. 15x divided by 5 is 3x. And then 5, I factored out the 5, so I'm left with 1. Now on the signs, because I factored out this negative, that means I'm taking the opposite sign of everything inside. So this negative 15, or I should say just going on the actual sign, this negative sign became positive, this positive sign became negative, okay? And if you don't like that rule to try to remember, if it throws you off, like factoring out a negative, you're doing the opposite, the division method still works. I removed a negative 5. So negative 15x divided by negative 5 is positive 3x. Positive 5 divided by negative 5 is negative 1. So you can also use that method as well, the division method. Okay, so once I did that, I noticed, oh, I have 3x minus 1 and 3x minus 1, a common factor. So I pull out the 3x minus 1 from both terms, and I'm left with 4x minus 5. And that's my final answer. All right, moving on to example 3. So on this one, you'll notice that we're still, once again, doing the same type of problem, but the signs are different than what we've practiced on example 1 and example 2. So on this one, we have 2 negative signs. So what you're going to notice is that even though solving these problems by grouping is a little bit different from what we did in section 6.2, there are similarities because depending on the signs that are within the trinomial, we're still using the same method that we did in section 6.2. The signs tell us everything in terms of how the factors are going to add or subtract to equal what we're looking for. So I'm going to go ahead and get our example up and we're going to work through it. Okay, now something I do want to point out on this one, I want you to look at it carefully. What do you notice about it? Okay, if you notice that they all have a y, before I solve this problem, this is the #1 rule of factoring. It doesn't matter what type of problem that we're doing. In this case, we're practicing with factoring trinomials into a binomial set, but I notice that they all have y. So anytime you start a problem, always look for a common factor. So in this case, because they all share a y, before I even start looking for factors and numbers of coefficients, I'm factoring out this y. So now if I take away the y, I have 6x squared. If I take away this y, I'm left with 7x. And with the removal of this y, I'm left with 5. So now I'm back to my normal trinomial set. But something that you have to remember is that any time that you have to factor a term out before you start factoring into binomials, this factor has to be a part of your final answer. So from this point on, I'm going to rewrite this y on the outside of any parenthesis set that I have. Okay, so in this case, we're looking for factors of 6 and 5, okay? Now notice this is negative. So this time, because this is negative, that means we're looking for different signs. One factor is going to be positive and one factor is going to be negative. So I'm going to go ahead and write that 6 times 5 equals 30, okay? So I know that we're looking for factors of 30. But when I draw my factor list of anything that can multiply to equal 30, in terms of what goes in the middle, we're looking for terms that subtract to equal 7, okay? anytime this is negative, the second sign is negative, we're looking for what they'll subtract to equal. You could also look at it as adding as well, because if you add a positive number to a negative number, then essentially it's still going to make a difference between the numbers rather than getting larger or smaller. If you were to add like two negative numbers together or two positive numbers together, it is going to create a difference between the two. So of my factors of 30, I need two factors that subtract to equal 7. And we'll determine what the signs are those on both of those numbers are once we figure out which ones we're working with. So I know 1 and 30, that's not going to work. 2 and 15, that's not going to be enough. 3 and 10. All right, it looks like 3 and 10 is going to give us a difference of 7. Now, once you decide what the factors are, this is where you have to look at the sign on B. If the sign is positive, then you're looking for these two numbers to add or subtract in a way that will give you a positive answer. But in this case, it's negative. So I need one of these to be negative. Which one can I give the negative to in order to make it result in negative 7? Well, if I put the negative on 3, 10 minus 3 is positive 7. So that's not going to work. But if I put the negative on the 10, 3 plus negative 10 or 3 minus 10 equals negative 7. So that's what I'm going to use. So I'm going to go ahead and write y parenthesis 6x squared plus 3x minus 10x minus 5. So I took my factors, one with the positive, one with the negative, and rewrote it and closed my parenthesis. All right, so what's the next step? I need to group them. These two and these two. Notice I did put the negative sign in with my negative 10x. All right, so I'm going to go ahead and rewrite my y and then parentheses. So we're going to have a little bit of crazy parentheses going on right now. So I'm going to factor out between these two. I notice that they both have a 3 in common, and I notice they both have an x. All right, now draw another parenthesis. Okay, so what's left behind? 6 divided by 3 is 2. I had an x squared. I removed one of the x's, so I'm left with x. Plus, the plus sign carries, 3x, and I removed the 3x. So what does that mean? That means I have a 1 left behind. All right, so looking at both of these, I notice they both have a negative sign. So I'm going to factor out that negative, and what it's going to end up doing, once again, we talked about factoring out a negative, you're taking the opposite sign. So what's actually going to happen when they both have a negative is that they're both going to become positive. So before I do that though, let's look and make sure they have any other factors in common. So we have a 10x and a negative 5, or 5. So they both have 5 in common. All right, so what's left behind? Draw another parenthesis set. We already discussed how factoring out the negative now turns both of these positive. So 10 divided by 5 is 2. The x remains. It is going to be positive now. And then 5, I had a 5, I took away the 5, so I'm left with 1. All right, looking at both of these factors, and I'm just going to close that off from this one that I started over here. You could also, whenever you have multiple parentheses going on, you can also do brackets if having multiple parentheses kind of throws you off. Okay, so I noticed that both of these have a 2x plus 1 factor. So I'm going to write y 2x plus 1, and then I'm going to write another binomial set, writing what's left behind. So if I take away the 2x plus 1, I'm left with 3x. If I take away this 2x plus 1, I'm left with negative 5. Close the parenthesis. So notice this y carried from the beginning as a factor. So if all you gave me in the end was 2x plus 1 times 3x minus 5, and you didn't keep that y as a part of your answer, that means that it's wrong. That y has to remain. All right. So I'm not gonna have y'all do a practice one on this one on your own, but I believe I did at least put one on your homework that you'll get to try. And you can always come back and rewatch this video if you need to see a negative trinomial done again. All right, moving on to example 4. Same method, just a different set of signs. Okay, before I start, I want you to look at it and see if you can identify what your first move would be. Okay, so something I notice is that these are all even numbers. So there's gonna be some type of factor that they all share. Another thing I notice is that they all have y's. So that means we're gonna need to do some factoring before we factor them into binomials by grouping. So I see that for my y's, I have a y to the 5th, the 4th, and the 3rd. Greatest common factor goes with the least exponent, so that's going to be a y to the 3rd. For the numbers, 12, 10, and 42. Well, I think 10 is going to be the one that limits us because 10 only has 2 prime factors, 2 times 5. Obviously, none of these are a factor of 5. So that means the only thing I can factor out is a 2. So we're gonna have 2 y to the 3rd. And I'm gonna go ahead and write what's left behind. So 12 divided by 2 is 6. I had 5 y's, I took away 3, so I'm left with 2. Plus sign carries. 10 divided by 2 is 5. I had 4 y's, I removed 3, so I'm left with 1. The minus sign carries as well. 42 divided by 2 is 21. Y to the 3rd, I removed it, so it's no longer there. Okay, so this is actually a good time to have a calculator, but I think I can do this in my head. Looking at the next part, we're now gonna move on to factoring by grouping because this has a coefficient larger than 1. So we do need factors of 6 times 21 that are going to give us our middle number, okay? So 6 times 21 is 126, I think. Let me just double check on that. 120, yeah, I think that's right. Okay, so if you look, we have a negative sign. Once you have your factors, or once you have what you're looking for factors of, go ahead and look and see what this sign is. If it's positive, that means they're adding together same signs. If it's negative, that means they're subtracting to equal this middle number. So what I'm gonna be looking for when I make my factors of 126 is 2 factors of 126 that subtract to equal 5, not add. So let's go ahead and take a look at our factors. I know that 6 and 21 are factors because I had to multiply them to get 126. Something I also notice is that 21, let's see, 21 and 6. Okay, so those aren't gonna work. So that means we're gonna have to make more factors to equal 126 that subtract to equal 5. If you have a calculator, feel free to use it. I didn't bring mine downstairs because I didn't think I would need it. So we're just gonna work through this. Well, you'll work with me by hand on this, but when you take your test, of course, feel free to use your calculator if the numbers are a bit too big for you. All right, so I know it's not 1 and 126. I'm going to actually factor this so I can see what I'm working with. Okay, so to give you a little shortcut method, you can actually make the factor tree and then make new factors of 126 that way. So I know that we'll take 3 times 3, 9 times 2 times, so 9 times 14 equals 126. Does 14 minus 9 equal 5? Oh, actually it does. Okay, so we got it. All right, so we're gonna be using 9 and 14. So that was fast, I just got lucky on that try. So 9 and 14, one of them is going to be positive, one of them is going to be negative because this is a negative sign. They're subtracting to equal 5. So what I need to identify before I rewrite my problem is which one is negative. Is the 9 negative or is the 14 negative? So the way I need to look at it is how can I add them together or subtract them in a way that will give me a positive 5. So if I put the negative on 9, does 14 minus 9 equal positive 5? In this case, the answer is yes. So I'm going to rewrite 2y to the third parenthesis, and then 6y squared, instead of writing 5y, I'm going to write minus 9y plus 14y minus 21. Okay, this is where we're going to start our factor by grouping. So go ahead and put parentheses around your groups and make sure that the sign is included in the second group. Okay, so in this case, to make it where it's not as confusing, I'm going to actually put brackets to take away the 2y to the third for right now, and then in the end, I won't need the bracket. So 2y to the third on the inside. In this first grouping, 6 and 9 both have a factor of 3. Y squared and y, that means they both have a factor of y. Okay, so draw my parenthesis. What's left behind? Well, 6 divided by 3 is 2. Y squared, remove a y, I'm left with a y. 9 divided by 3 is 3. Notice I carried the negative. I had a y, I took away the y. Okay, so that one's done. Okay, in this case, since I have a plus sign on my 14, I'm going to go ahead and keep that plus sign. So because I'm factoring out a plus, that means that I don't have to change the signs on this one. Okay, so that's going to stay the same and that's going to stay the same on my signs. So now I need to look at my numbers, 14 and 21. What do they both have in common? They both have a 7. So what's left behind? 14 divided by 7 is 2, and then of course the y is still there. This minus sign stays. 21 divided by 7 is 3. All right, and then I'm going to close my bracket. Okay, so notice in the bracket, I have my, or outside of the bracket, I have my 2y to the third, and inside is my factor by grouping. So now, to finish this up, I don't need the bracket anymore. I'm going to write 2y to the third parenthesis. Now, the parenthesis is going to be what I'm factoring out because notice we both have a 2y minus 3. So when I factor out that 2y minus 3, what's left behind? I draw my other parenthesis set. I'm left with a 3y, and I'm left with a plus 7. And that's your final answer. Okay, so on example 4, you go ahead and try the practice problem. This is going to be on page 398, kind of in the middle of the page. So go ahead and try that one on your own, and then you can refer back to the board. I'm going to erase this, and I'll have it for you to check your answer. Whoops, I guess I didn't need to do that. Okay, so on this one, I did have to do some pre-factoring. They both had a common factor of 5 and m squared. So what's left behind was 8m squared plus m minus 7. From there, then I looked at my factors of 8 and 7 that equal 56. So what I needed, because this is negative, I need two of them, or well, I need one of them to be negative and one of them to be positive. So I'm looking for what subtracts to equal 1. Well, I didn't have to do any more factors of 56 because 8 minus 7 is 1. So which one is negative, which one is positive? Well, I'm looking for a positive m, so 8 minus 7 is positive 1. So I rewrote that, keeping my 5m squared on the outside, 8m squared plus 8m minus 7m minus 7. Then I grouped them to the first two and the last two terms. From there, I did factor by grouping. So I pulled out 8m here and had m plus 1 left behind. I factored out a negative 7 from the second group. So because I factored out a negative and they're both negative, that means the inside becomes completely positive. So I'm left with m plus 1. They both share the factor of m plus 1. So I pull that out, and then 8m minus 7 is left behind with the 5m squared that we factored in the beginning as part of the final answer. All right, so guys, we are almost done. As I said at the beginning, this section is a lot shorter compared to other sections that we have covered. So if you haven't looked ahead, this is going to be our last example of 6.4. Okay, so 9x squared minus 42x plus 49. All right, what's the very first rule? Look for something that can factor. So let's take a look at, obviously, the variables. This one doesn't have one, so we can't do anything to that. The next one is the coefficients. So I notice that they all have a 3 in common. So I'm going to factor out 3. I have an x squared. Sorry, I didn't write the leftover coefficient. So 9 divided by 3 is 3, and then I have x squared minus 42 divided by 3. So that's 14. The x remains, plus 49 divided by 3. No, wait, actually, I take that back. Yeah, 49 is not going to work. I must have looked at that number wrong. I think I might have overlooked the 4. Thought I said 9. Okay, so actually, going back, there is no common factor. So we are going to have to be working with pretty large coefficients. I'm just going to double check to make sure. Yeah, I did write that down correctly from at least what I have on the PowerPoint slide. Okay. Okay, so I'm going to actually go back and read what we have here, because the purpose of this problem is that we are trying something new that we haven't done before. It's really not going to affect the process. It's more just going to affect how you write your final answer. But since we're going to have to start all over again anyways, and I figure, you know, we might as well go over it. So it says if you end up in your final factored groups with identical binomials, write the binomial once and then square them. So obviously that's not going to hit us until we get to the answer portion. So looking at this, we have a minus sign here and a plus sign here. So we're going to end up looking for two factors of 9 times 49 that add to equal negative 42, because this is a plus sign. So, I don't have my calculator, but actually, you know what? We can make this work. We're going to use the same method we did before, where we're going to use the prime factors of our two multiples to make different variations. If you have a calculator though, then, you know, feel free to explore. But what we know right now is that we have to do 9 times 49. I don't know what that equals, so, but fortunately I actually do have a calculator on my phone, so we're gonna do that. Okay, so 441. So that's a large total to work with, but we're gonna use the method I used earlier where we're gonna actually break these down into primes. So 7 times 7 and 3 times 3. So, we have 21 times 21 because 3 times 7 and 3 times 7. And we're looking for negative values. So I could say that negative 9 times negative 49 is 441. I can say negative 21 times negative 21 is 441. Now, I noticed something. We are looking for them, because this is positive, we are looking for them to add together to equal negative 42. Well, what's negative 21 and negative 21? Negative 42, so we did it. So it didn't take us too long to get into it. So we don't have anything that factored out in the beginning, so I know that we're not gonna have to worry about carrying a factor the entire time. So what we're gonna do now is just rewrite our problem with the new factors, 9x squared. They are both negative, minus 21x, minus 21x, and then plus 49. All right, so now we're gonna group them. First two, last two. In the first group, do your coefficients first. 9 and 21, what do they both share? They both share 3. X squared and x, they both share an x. So what's left behind? 9 divided by 3 is 3. I had 2 x's, now I have 1. So 1 x is left. The minus sign stays. 21 divided by 3 is 7. I had an x and I removed it. So this is what I have in the first group. All right, I have a negative sign and a plus sign. Because this is negative, I'm going to go ahead and factor out that negative. So what that means is that everything in the way this is grouped right now is going to change their sign. All right, so looking at what are we factoring out other than just the negative, I have a 21 and I have 49. What do they both share? They both share 7, okay? And then of course they don't have a variable in common, so the x is just going to stay here with 21. Okay, what's left behind? 21 divided by 7 is 3. And then of course the x is still there. And notice, because I factored out this negative, this becomes positive. You could also look at it as negative 21 divided by negative 7 is positive 3. All right, here I have 49 divided by 7, so that's going to give me 7. As far as the sign, this was positive. This negative makes it negative. You could do 49 divided by negative 7. You still end up getting the fact that this is going to be, that this is going to be negative. Okay, so regardless of how you look at it, the sign changed. So it was positive, I factored out a negative, so it becomes negative, the opposite. Or 49 divided by negative 7 is negative 7. All right, now what do I notice now? I have a 3x minus 7 and a 3x minus 7. So I'm going to factor out 3x minus 7. What am I left behind with? 3x minus 7. Now here's where that statement was from the very beginning. It says, I'm going to read it again. If you end up in your final factored groups with identical binomials, so 3x minus 7 and 3x minus 7 are identical, don't keep it looking like this. You need to rewrite it as a square. So what I would do is, since I have 2 of them that are the same, I write it once and I put a 2 up here to show I have 2 of them. Okay? Well, that concludes our section 6.4. If you have any questions, just reach out to me. The homework assignment is already available on Canvas. I will have the video for 6.5 coming to you really soon, so that way you can go ahead and get the entire homework assignment completed, since it does include 6.4 and 6.5 as one assignment. So just let me know if you have problems or questions, and I'll get back to you as soon as I can. All right, thanks. Bye.